Good morning and welcome to the AWS Public Sector Summit Singapore. I'm your room host, Matthew. We have lots of good sessions in store for you today. As you move between sessions, please take your seats promptly to ensure speakers are able to start on time. We're pleased to advise you that all AWS sessions you see today are being recorded and will be available after the event. If you would like to access the slides today from any sessions, please approach one of our staff and tap your badge on the touchpoint at the front of the room after each session. Finally, all of you have a QR code on the back of your badge. You can use this, or the URL, to provide feedback on any session you see here today. We would love to hear from you. With your help, we promise to always look for better ways to run these events. In addition, we will be randomly generating a winner per session from the submitted feedback pool, who will walk away with a limited edition swag. Winners will be announced at 1 p.m., 4 p.m. and 6 p.m. respectively in the rooms. I would now like to introduce you to our first speaker, Dennis Magzaho, Solutions Architect, Worldwide Public Sector, AWS. Please welcome him to the stage.
Hello. All right. Good morning. That was a very interesting introduction. Wow, the lights are... Okay, so how's snack? Oh, cool. Right. So it's sort of a challenge in the sense that this is the first semi-technical session right after the keynote. So I won't shock you by putting in too much technical details into it, right? So I'll be discussing about, well, it's a quite popular term these days, so serverless and microservices, right? So there are a lot of services, AWS services to be exact, that would be touched on throughout the presentation, but I will not be going through each one of them in detail. There would be other sessions, like, for example, relational databases. There's, in fact, one for serverless functions later on the sessions. But in this case, I will be mentioning them, but it's more in the context of serverless and microservices. Good? Right. OK. I was introduced, right? So, yeah. Right, so show of hands, who are doing serverless now? Wow, really? Okay, right, so with regards to serverless, there are a couple of things that, well, that would stand out. One, of course, there are no servers, right? So, but technically speaking, it's not really that you don't have servers, but you actually do not manage the servers yourselves. Right, so that's one, of course, is the key factor. It also scales with usage. So you don't, since you're not worrying about how many servers I have, it doesn't really matter if you do 1, 10, 200, 1,000, right? You shouldn't be caring about those. You never pay for idle. So this is something that would be emphasized later on, in the sense that if you are running a virtual machine or a server, on a per hour, per second basis, or even a year basis, you pay for it whether it's idle or not. So this is something that serverless can actually address. And of course, in the same manner that you would expect some level of availability and resilience to your servered applications, that should be expected on serverless as well. Okay? Now, we have had AWS services for serverless. You might have heard of AWS Lambda, which is our serverless function. And of course, Amazon API gateways that can be used to invoke Lambda functions. So it's just like invoking, let's say, an API REST call, HTTP, calling a Lambda function to perform the function for you. But, of course, these are the more popular ones, but there are a lot of services that we consider serverless if you are performing implementation or architecture for your application, right? So we have services for storage, like Amazon DynamoDB, Amazon S3 is very popular when it comes to storing data. And of course, we have security services like Amazon Cognito for user pools, and then streaming data with Amazon Kinesis. So there are a lot of services in your arsenal if you are going to build serverless applications. And then, of course, more recently, there have been advances. You know that we come up with services in a high rate, right? So Amazon Aurora Serverless is for relational databases. This is a MySQL edition. And then, of course, later on, I will be telling something about Fargate. AWS Fargate is a serverless container service, right? OK, so next question. Again, show of hands. Who are already doing microservices or considering microservices? And OK, so it's equal. It's like equal amount of serverless and microservices. So the concept behind microservices is you try to make things small, hence the term micro. That is in terms of managing the code itself or the application itself, right? And at the same time, since these are small, isolated services, whenever there's failure, you actually limit the impact of the failure, right? So it's not something blows, like if something blows up, it blows up the entire application, right? So they have their own data, and of course, they are resilient. So how does now serverless relate to microservices? Because you can do microservices without doing serverless, right? So they are aligned in a sense that a lot of the features that I'll be discussing later are actually aligned to doing or conforming to the pillars of microservices. Some of them out of the box, meaning once you use this serverless service, it addresses a microservice requirement. Some of them are not really out of the box, but at the least it's easier to implement as compared to, let's say, doing traditional way of doing microservices. But the second to the last, serverless is not a silver bullet. So it's not like, OK, serverless is so good. Let's all move to serverless, right? There would be cases that you would be requiring servered sort of components, right? So it's a matter of getting the right fit, picking the right services, and making sure at the end of the day, your applications, your customers get what they need. OK? So going back to microservices then, right? So these are on the left side. Your left. We have like two major business goals. One is faster time to market. So how does that work? Because if you're dealing, remember, I've mentioned that we reduce the size of the code, right? But with that reduction, you reduce the risk of failure, but at the same time, it has to be frequent, right? So now it's agility. We have to move fast, right? If you get a small, if you want a small enhancement, then put it in. Let's test it. If it fails, we recover. Then we do it again and again and again and again. So that is on the faster time to market. And at the same time, since you've broken down your monolithic application into smaller chunks, you can actually move and assign them to different teams. So that's ideally speaking, you now have separate teams that can manage a particular component, right? Now, to come up or to achieve the business goals, there are design pillars that you would have to consider. Resilience is one. It has to be highly available. It should scale. That's one of the reasons why I went serverless, right? I don't want to worry about the number of servers that I'm maintaining. And at the same time, the continuous delivery part, which addresses the time to market business goal, right? There has to be automation. There has to be a set of processes, and there has to be there should be services that would help me, right? Do faster time to market. So I'll be going through the different pillars. So the first one is resilience, right? Of course, in AWS, we design for failure, right? So failures will happen. It will fail, right? There would be like people saying, we should plan that it should be 100% up and available. But the thing is, it will fail. So we plan for that one. So and at the same time, there are some considerations like throttling that you would have to consider. I'll show an example later on throttling. And of course, the functionality that if something fails, how do I retry? When do I retry? And let's say if it takes too long, I should have the capability to stop the processing and then either perform a retry or handle the error. So we have features for that one as well. So I'll be addressing the high availability first. So we have a couple of services that you can use for resiliency. So in this case, I can set up an application, let's say coming from a mobile application, and I'll be utilizing AWS regions. It can be, in this case, it's US East 1 and East 2. An API can traverse the different regions. So in this case, if, let's say, one of the regions have a problem with network and the latency goes down, then you would have the capability to redirect the request to the surviving region. Right? So that's what high availability is all about. You should have redundancy such that if one fails, there's another one to actually cater for the service. Okay, so again, diving deeper into the functionality of API gateways, you are able to specify throttling and quota. Now, you might be saying, why would I throttle my application? Imagine this. You have an application, a front end, that is talking to a back-end database. Right? So you know that my database can only handle this much requests and workloads. Right? So what you do now is you throttle the front-end service such that it controls the transactions going into your database. Why would you do that? Well, it would probably be easier to manage throttling on the application side than to recover from a failed database. That's why throttling is there for you to be able to design your applications to handle them. Then, of course, another function is the timeouts. So the AWS Lambda functions, our serverless functions, you are able to set timeouts. So you cannot have the Lambda function run for 3 years, right, waiting for it to finish. So there has to be a means to set a timeout such that this is the only allowable time I would want my process to run. And if it fails or if it exceeds the timeout, you should be able to either retry or go back and handle the error. Right? So these are the functionalities that we offer, or features and services, to address availability. And of course, you should have a means to see what's going on. That's why we have Amazon CloudWatch. It's our application and infrastructure monitoring service. So in this case, you would know the number of failures, latency. Probably you would have metrics for that as well. And on the left side is a service that we use. It's a tracing, analysis, and debugging service for distributed applications, which is very typical to microservices. So since we have broken down the application into smaller chunks, it, in a way, is distributed. And AWS X-Ray does the monitoring of where did my transaction go, how is this component doing, and all. So these are services that would help you sort of rate or monitor the availability and resilience of your serverless application. Right, so we've tackled availability. Let's go to scalability. So in terms of scalability, I would want to address two different layers. One is on the storage, and the other one later on is on the compute. Okay, so to sort of better explain the scalability capability of our storage services, let's go through the concept of what we call a data lake. Right? A data lake is interesting because it requires, on the left side, on the right side, or your right, it's a virtually limitless centralized storage platform. So virtually limitless. So that's where the scalability comes in. So you don't have to worry about chassis. You don't have to worry about how many petabytes, how many free space, etc. Right? So, and it's decoupled. Decoupled is very important in a serverless architecture. I will sort of discuss that later as well. And at the same time, the capability to ingest data and perform transformation. Of course, your storage, if let's say you're scaling your users, you're scaling your applications, but your storage cannot keep up in terms of ingestion, then that's just bad. Right? So the data lake, or in this case, the underlying storage, should be able to handle that. So our choice for that is Amazon S3 for data lakes. You do get a lot of benefits from using Amazon S3. So there is security. There is object level control. Of course, there are monitoring, and then probably business intelligence or reporting on top of it. But the feature that is in line with our topic is the unmatched durability, availability, and scalability. Right? You don't have to worry about if my disk gets full or not. So that is why S3 is a good choice if you are going or considering going to a serverless microservice implementation. S3 would be able to handle files, objects. But what if you're dealing with relational data, or in this case, or probably non-relational data as well? So we do have services that caters for serverless storage of relational and non-relational data. Okay. First one, of course, is we have Amazon Aurora Serverless. So you might have heard of Amazon Aurora Postgre and Amazon Aurora MySQL before. So this is part of our relational database service offering, which we will have a separate session for that. But in this case, Amazon Aurora is, in a sense, serverless. So you don't have to worry about that particular instance. If you need more database resources, then it goes up. And if you need less, it goes down. So that is the concept of being serverless for relational databases. And at the same time, of course, on your right is the Amazon DynamoDB, which is our non-relational database service. Right? Same concept. You just insert your data, you manage it. You don't have to worry about the server or the instances. So that takes care of your object data, relational data, and non-relational data. OK, so let's go to the compute side of things. I've mentioned about storage, so the second part is compute. I remember I was asking, like, who are those doing microservices? Right, so when you say microservices, sometimes that is actually related to using Docker containers or containers, generally speaking. So that's what the first thing that comes to mind. So microservices, then OK, then let's use containers. But if you would be using containers, whether you run it on premises, whether you run it virtualized in AWS using EC2 instances, and whether you're running it with our Elastic Container Services, you would still have to maintain the cluster of EC2 instances serving your containers. And you are charged for using that. So we came up with AWS Fargate, where the granularity of you managing goes to the task level. I spin up an application. It can be like a task. It can utilize 3 separate containers. It spins it up. Then if it finishes, it shuts it down. You only pay for the time that your task was running. Right? So in this case, again, since this is serverless, you only manage your tasks. You don't have to look into the EC2 cluster. Right? So in this case, there are no instances to manage. The task is, they use native APIs, so Docker APIs will work. And it's resource-based pricing, as I've mentioned earlier. OK, so of course, going back to the most common service for serverless, we have the serverless functions, which is AWS Lambda. So how do you scale them? Well, it scales, but you don't need to worry about that. Under the hood, it's using container technology, right? So you just spin the function. If it finishes, you don't have to worry about anything else or managing whatever is the infrastructure underneath it. So they just scale. OK? Right. I mentioned that decoupling is very important. Once you've broken down the architecture into smaller chunks or layers, right? So I mentioned we do that to lessen the impact of failures. One of the more important things that you would have to consider is how does my compute integrate, let's say, with my storage, right? Or how do processes or functions communicate with other functions? Because we've decoupled them. Before, it was like one monolithic application where all of them share the same data or variables. But since we've broken them down, there has to be a means for them to communicate. Right? So we do have a couple of services for that as well. So depending on how you would want to execute your integration, you can either push using Amazon API gateways. So you make HTTP calls, right? And then the function fires. You wait, you get the data, and then you process. We have asynchronous events. So we can make use of Amazon SNS, or Simple Notification Service, where data is put in a buffer, and then asynchronously, processes can pick it up, do the processing, and probably insert a reply back or do something else. And we have, of course, Amazon S3 again as an intermediate sort of store, where if you store or write something into S3, it can invoke a Lambda process to perform operations on the data that you just uploaded. And of course, they're stream-based. So stream-based meaning data continually goes in. So we have Amazon DynamoDB for transactions, and then, of course, Amazon Kinesis, which is our data streaming service, both of which can invoke or could fire up Lambda functions. So looking at this, looking at Lambda, looking at the previous services that I've mentioned, you can now tie them together. Right? So I'm not sure if, do we have a lot of developers in the room, presumably? Remember when we were in college and the first things we learned were declaring variables, execution of statements, begin, then end. So that's one big application. And then in your first year at the university, you have like 1,000 lines of codes because you didn't know how to put them in libraries. So it's just one big main function. So imagine that concept as your monolithic application. But now we have the capability to have variables in the form of DynamoDB S3. We have your individual statements in the form of Lambda functions and step functions. And then you just tie them together to operate as one. Right? So that is something that you may want to consider. Right. And of course, the last pillar is into continuous delivery, right? You might be saying, okay, that's well and good, right? But when you're doing serverless and microservices, it's so easy to like, okay, I'll create a Lambda function and it will say hello world, right? So, okay, we were able to do hello world. Now can we like link that once it says hello world, it asks for user input. So it keeps growing and growing and growing. So it has a direct effect on how you operate things, right? So the process now becomes very important, not just the technology, right? So like how often do you build your application? Do you do it nightly? Are you looking into the DevOps bandwagon? Do we do like nightly builds? Do we release every week or do we release every year? So those are procedural considerations that can be supported by technology. So what's a good process? So there are a couple of things that I would want to highlight in line with the faster time to market business goal. So it has to be easy to interpret. We go back to the frequent and small changes. And then the impact, as I've mentioned earlier, should not be huge. So we try to reduce that. And of course, automation is very important. Automation in a sense that if you do something, there's a chain of events that will happen, whether there's approval or not, to help you move quicker, right? So each one of them, I'll be sort of like briefly mentioning about a particular service or feature. In this case, easy to interpret. We have what we call the AWS CloudFormation. It's infrastructure as code service. So if you are, let's say, if you would want to build an application in AWS, you can have a CloudFormation template, which is like, well, it's a file that would contain the different components. And if you want to deploy them, you just send that template, and AWS will take care of spinning up or building the services that you specified. With the AWS Serverless Application Model, or SAM, we made it more. We made it easier. such that if you are using a CloudFormation template and it uses Lambda functions, API gateways, DynamoDB, or some other serverless service, with fewer codes, it executes the same as with CloudFormation. So we have improved and extended CloudFormation to handle serverless specific components. Right? So instead of, let's say, maintaining 25 lines of codes, it could be 5, it could be 10. Right? So it lessens the length of the template that you're using. And at the same time, as with AWS CloudFormation, you are able to deploy that with other services as well, including code pipeline. Okay, so that's for easy interpretation. With the same function, or the same feature, or with the same tool, we have now what we call, it was previously SAM Local, but now we call it AWS SAM CLI. So anyone has used Lambda before? Lambda. Okay, quite a few. So for you to, prior to you to test your Lambda function, you, of course, would have to deploy it and see how it functions on the cloud, right? So it requires internet connectivity. There's latency because you're sending data from your machine going to AWS, for example, right? With SAM CLI, you now have the capability to test Lambda functions on your machine. So if you're working on a laptop or a PC or a Linux box, you can test your Lambda functions without needing to deploy them to AWS. Right? So what it does, it spins up a container that emulates the environment of a Lambda function. Right? So with that, you now take away the latency of having to send your code back and forth. So quickly, you can develop, and you can even do that without the internet connection. And come the time that you would want to deploy, then you do the deployment to AWS. So that is on the frequent and small changes. OK, so what about controlling the impact? What if, OK, I deployed my Lambda function. It's a very critical Lambda function. But suddenly, I realized there's an enhancement or a change that I would need to do. OK, but it's live. It's production. OK, so this particular feature, would now enable you to create versions of your function such that you can deploy a version 2. And then, once you deploy, you tell AWS, I only want 5% on this new code, and then 95% on my production code. So at least that 5%, those are the ones at risk of maybe getting a failure because it's new. Right? So now you have the capability to do canary deploys. So you can put weights. I think the third command actually puts the weights on the distribution of requests that would be executed by your Lambda versions. That's version 1, and that's version 2. OK? And of course, this is one if, in terms of the overall workflow of development, we have our AWS code services. So I have seen a couple of customers using code services. And it puts together a lot of tools for developers like IDE, the automation of compiling, building code, etc. So going through the services, on the third icon, you call it AWS Code Commit. That is a Git-compatible repository. So if any one of you are using, probably you are, GitLab or GitHub, it's the same thing. So you use the same client. But in this case, this is a repository in AWS. Okay, so that's the first part, storing your code. The second one is building your code. So that's AWS Code Build performs the building and the testing of your artifacts. So if you want, let's say, if you want to automate that every night, I would want to compile my Java code, the .java, and convert it to classes, and then package it into a WAR file, an EAR file, or a jar file, you can have that automated. And you have code deploy, Code deploy would help you automate deploying through the different environments that you might have. I may have a dev, I may have QA, and I may have production, and the code deploy would help in doing that. And you also have code pipeline, AWS code pipeline, which stitches them together. So code commit, which is the store, then you build, then you deploy. Then it monitors the execution for the different components. And one of, my personal favorites is AWS Code Star. So it takes all of those on top, pipeline, deploy, commit, code build, and puts it in a service where if you create it, it gives you an IDE. So we have Cloud9, which is our cloud IDE. You will have that. Of course, you still have the choice to move. Let's say if you're using Eclipse or some other IDE, you can still use that, but we give you that option. And then it actually, apart from the services, you have integration with Jira Atlassian. So if you are looking into ticketing, into project management, there is integration that you can use. Okay, so the Code Star makes it easy to start us with, the topic is getting started easily with serverless and microservices. So one suggestion, once you get out of this session, try to start up a serverless application using Code Star. So it will create all the needed components that you would require to run a serverless application. So it will ask for a repository where you will be keeping your code. It will ask you if you're going to use Cloud9 as your IDE or have some other IDE for that one. And it will give you sample codes. And in fact, once you click the endpoint, it will show you the initial application. And then you can do modifications as you'd want to it, right? You can also provide with, remember I've mentioned SAM, the YAML files for the configurations for serverless, right? Right, job 0 for AWS is security. So as with any service that we introduce, security is our foremost concern. So that is something that we extend to the customers as well in terms of capabilities. That's why we have fine-grained access control. So you can control the resources by assigning roles to the different serverless components that you're deploying. And at the same time, this is something that I would highly suggest, especially to those who are using Amazon S3 or our simple storage service. Try not to deploy S3 as public buckets. So I know developers it would be easier for developers, okay, I don't need to set the restrictions and all, right? But make it a practice to authenticate. You'll never know. You say, this is harmless data. Then it goes out and it's not really harmless. So that's a practice. Again, we will provide the technology, but it's still up to the customers to actually make use of that technology. And Amazon Cognito gives you the capability to do so by providing you with user pools for security. So instead of setting that S3 bucket public, create a Cognito user that you can get a token from so that it can authenticate. Okay? So don't just take our word for it when it comes to security, but we do comply with PCI and HIPAA when it comes to our serverless applications. So yes, we will say it's secure, but we have proof or we have attestations from third party saying that the serverless applications or services that you will be using is HIPAA or PCI compliant. Use cases. More often than not, I see web applications because these are the easiest to do. You just need to, if you are an HTML5 developer, or you do JavaScript, right? So you can just have a static website that calls API gateways that executes Lambda at the back end. Then you don't need to maintain service. Backends as well, if you would want automatically process files. In my case, I have this area where if I upload a file to S3, it fires and gets the metadata of the file and inserts it to a search engine. So automatically, when I load files, it does indexing for me. So backend processing, data processing can be done as well, but mind the timeouts for Lambda functions. So do not execute huge batch operations using Lambda, but you can insert it in a queue. Remember the decoupling that I've mentioned earlier? You insert something in S3, a Lambda function fires up, and then inserts it into a queuing or a notification service. And then at the back end, you can even have like Spark or some other processing engine that picks up from the queue. Okay, so artificial intelligence, chatbots, and automation. So going to the proof points, cost would be something that you might be interested in. Well, of course, you'd be. But again, it depends on the usage. Because remember, I mentioned that if you're running a server or an instance 24/7, you're paying for it whether it's idle or not. So customers find cost savings by using serverless instead. And we do have a lot of customers that have moved to that for different reasons, right? So of course, it's up to you to find whatever reason that would fit in your particular use case. And if you would want further information, so we do have a website for serverless computing. So serverless computing and applications, it has templates. So you don't have to start from scratch. We do have a couple of templates, and that would be CloudFormation templates or images that would help you get started with serverless. And with that, that would be my last slide. So the QR code would have to be shown, I guess. Right, so thank you. Thank you for your time.
Thank you, Dennis. If you have any questions about this session, you can find Dennis or any of the AWS architecture team at the AWS booth. Remember that we would love your feedback. Scan the QR code to have a say about this session and stand to win a limited edition swag from us. Thank you.